Alright, so let's go ahead and evaluate this limit. I'm going to substitute 3 in. Right away I know I have 0 in the denominator, but let's look at the numerator. 3 plus 6 is 9. If I take the square root of 9, that's 3. Minus 3 is 0. So I see that I have 0 over 0, which I know tells me I can remove the discontinuity. Now I'm going to show you how we can do that. We call this rationalizing. And all we have to do is multiply the numerator and denominator by the conjugate of the radical expression. What that means is, since I have the square root of x plus 6 minus 3, I make it the square root of x plus 6 plus 3. I have to multiply in the numerator and denominator because that's the same as just multiplying by 1, so it doesn't change the function. Since these are conjugates, I can just multiply the first terms and the last terms when I'm multiplying conjugates. And if I do the square root of x plus 6 times the square root of x plus 6, that's just x plus 6. Negative 3 times 3 gives me minus 9. I see in the denominator, these are not considered conjugates. They're two different expressions. So I'm just going to keep them separate for now. And you'll see why. I want to go ahead and simplify the numerator. I bring over my x, and then 6 minus 9 gives me negative 3, so I have x minus 3, and then I'm just going to rewrite what I had in my denominator. Now, you can see I have an x minus 3 here and here. That's what was giving me 0. Okay, so now I can write a limit that I know I can find. This cancels out, so that becomes a 1, because x minus 3 divided by x minus 3 is just 1. I'm left with the square root of x plus 6 plus 3 in the denominator, so all I have left to do is substitute. Three plus 6 is 9, so I have 1 over the square root of 9 plus 3. The square root of 9 is 3. 3 plus 3 gives me 6.